Hello everyone, welcome to the fourth lectures of the series Unit and Measurements. So today we will learn about the significant figures. So in these lectures we will cover how to learn how to identify the significant figures, how to do addition, subtractions, and also the divisions of the significant figures. So let's start. So now before we start, we must know what is significant figures. Okay, let us understand the development experiments. Okay, suppose we are given to measure certain length, and for that we have a scale centimeters. Okay, scale centimeters, and that scale centimeters happen to be this one. Okay, after here 2, after here it's 0. Suppose it's 0, it's 1, and then 2. Okay, this is a centimeter scales. Now we are measuring something length, right? So now that length happens to be up to here. So now by looking, what can you say? How much length will be this? So some of us may say this, that this length is 1 point, right? 1 is obviously, and after that 1.2, right? 1.2 centimeters some of us may say. Now some of us may say that after okay, coming here also some of you may measure like this, right? 1 and then 2, 3, 4, 5, 6, after that it will be 10. Okay, so now you see here in between also there is some length, right? In this between also there is some measurements. So now some of you may think that after dividing into tens, and then this will be something like 1.22 centimeters, right? Some of us may say like this also, right? After dividing this one, okay, the small that the length is extended little, so this way after here we will divide it up to the 10 decimal, and then it will be 1.22 centimeters. We will think that, right? So now some of us may be confident up to here, some of us may be confident up to here. Okay, we are sure that it measures will be this much, right? So now these digits, okay, that we are confident, okay, during the measurements, the digits that we are confident, okay, this digit we are confident, right? So these digits are called the significant figures. Okay, here how many significant figure is there? 2 significant figures. Here how many significant figure is there? Here 3 significant figures, because we are confident up to 3, right? So now significant figure means same only. Okay, significant figure means, okay, so it is the digit we are, it is a digit we are confident, okay, it is a digit we are confident in measuring, in measurement value. Okay, so significant figure means these are digits that we are confidence, okay, these are sure, certain, okay, the digits are called the significant figures. Okay, so now let's there are certain rules to identify the significant figures, okay, that we should know. So let's write down that certain rules, and then we'll understand one by one how to identify the significant figures. Okay, so rule 1 is that rule 1, okay, rule 1 is that all non-zero digit are significant figures. Okay, all non-zero are what? They are the significant figures. Okay, suppose examples, if we have this one 3, 2, 3, 2, then these are all non-zero significant, they are all non-zero digits, so these are all significant figures. So how many significant figures we have here? We have here 4 significant figures. Okay, number B, suppose like this 3, 2, 1. Tell me how many significant figures are here? Here 3 significant figures, because these are all non-zero digits, right? Rule 2, okay, 0 between 2 non-zero digit are, okay, 0 between 2 non-zero digits are significant figures. Okay, so examples, if we have like this, if 405. So how many significant figures are here? This 0 is between two non-zero digits, right? So this 0 will be also counted as a significant figures. Okay. So 3 significant figure here. Number B, if we have 4.05. So now this 0 is between the significant figures. So this 0 will be also counted as. This 0 is between two non-zero digits. Okay. So this 0 will be counted as a significant figures. Okay. So here also how much significant figures? 3 significant figures. Okay. Next rule, rule 3. The rule is that if number is less than 1, if number is less than 1, you know what are the number less than 1? Yes, 0.001, 0.002, 0.003. These are the number less than 1. If number is less than 1, then leading zeros, okay, the zeros that are at the beginning, they are not considered significant figures. Okay. If number is less than 1, then okay, then leading zeros are not significant figures. Okay. Example number A, 0.002. Tell me how many significant figures here. These leading zeros are not considered significant figure if number is less than 1. So only one significant figures. Okay. Similarly, if we have this one, 0.032. So tell me how many significant figures are here. So this will be not counted as a significant figures. Okay, this 0 will be not counted as significant figures because number is less than 1 and these are leading zeros. Right? So only these are the significant figures. These are the significant figures. So 2 significant figures we counted here. Okay. So next let's see. Yes. Next rule is that okay, trailing zeros, okay, or ending. Okay, trailing zeros or ending zeros are significant figure if they appear after decimal. So now, okay, if the 0 is at the last, if 0 is at the last and that is after decimal, then it will be counted as significant figures. Okay, example, see here, if we have like this 0, example A, okay, 0 point, suppose 0 to 0. So tell me how many significant figures are here. Tell me. See here, this 0 is appearing after decimals. Okay, after decimals, right? So this 0 will be counted as significant figure now. This 0 will be not counted because here we learn, right, in rule number 3 that starting zeros are not significant figure if it is less than 1. But if it is at the last, then it will be counted as significant figures. So here we have 2 significant figures. Okay. Similarly, B example 3.20. Tell me how many significant figures are here. How many? Here we have how many significant figures here? This is significant, this also, and this is also significant figures. So 3 significant figures. Okay. Next rule. Next rule is that number 5th rule. Okay. Trailing or ending trailing zeros, okay, are not significant figure significant figure if there is no decimal. Yes. Okay, so if there is any numbers and there is trailing zeros without decimal, if it is there, that zeros will be not considered significant figures. So example you see here. Okay, suppose we have this one 3200. Okay, so now this zero is trailing zeros at the end. Okay, so now this zero will be not considered significant figures. It will be considered significant figures if there is decimals. If there is decimals, it will be considered significant figures. But without decimals, this zero cannot be a significant figures. Okay, so here we have only two significant figures. Only these are the significant figures. Okay, number B. Number B we have 3020. Tell me how many significant figures here. Tell me. This zero will be not counted as significant figures, but this zero will be counted as significant figures now, because it is between two non-zero digits. So these are the significant figures. Okay, but this one is not. Okay, so three significant figures we have. This is not the significant figures. Okay, next rule. Next rule is that number 6 rules. Okay, number 6 rules. Okay, power of 10 are not significant whenever you come across power of tens. Okay, this power of 10 will be not considered as significant figures. Examples, if I have this one. Okay, 3.0 into 10 to the power 4. Tell me how many significant figures are here. 3.0. Yes, this will be not considered significant figure. Power of 10 are not significant figures. Tell me here. So here this 3 is significant figures and point is there. After decimals, trailing zeros are significant figures. So here we have two significant figures. See, don't make the mistake. Okay, two significant figures. Number B. Okay, 4.50 into 10 to the power 3. Tell me fast how many significant figures are here. So this 0 will be counted as significant figure or not? Yes, it will be counted because it is occurring after decimals and it is at the end. Okay, so that's why it will be counted as significant figure. So three significant figures are here. This one is not significant figures. Okay, now the seventh rule. Now the seventh rule is that seventh rule is that if there is change in unit, okay, wherever there is change in units, okay, if there is change in unit, then significant figure will not change. Okay, it will not change. Examples, we have, suppose in 1 kilometer, how many significant figures is there? 1 significant figures. Okay, so now if I convert this units, then it will be thousands, right? Thousands meter. So tell me how many significant figures are here now? Trailing zeros are not significant figures, so these are not the significant figures. Here also we have only how many? 1 significant figures. Okay, now you tell me one thing. If I write this one like this, tell me which one is the correct one. Okay, tell me which one is the correct one. This one, can I write like this? 1.0 into 10 to the power 3 meter, or I will write like this, 1 into 10 to the power 3 meter, or 0.1 into 10 to the power 4 meter. Tell me which one is the correct here. Tell me. Okay, you just think and tell me which one of these will be the correct. Okay, so now you will see here how many significant figures we have here. Only one. right? So now whenever we convert, it should also have the one only significant figures. So how many significant figures are here? There is two significant figures, you see. This one is a significant figures, this 0 is also significant figures, appearing after decimals, right? So two significant figures we got here. Here one significant figures and here we got two significant figures. So this one is wrong. Okay. What about this? How many significant figures here? One only. What about this? 0.1. Only one significant figures. After point only one number is there. So this was correct. But this one is not. Okay. Next we have this one. Okay. Last rule, number 8. Okay. Last rule is that if measurement is fixed, okay, if measurement is fixed, if it is the certain length, okay, that one is fixed. If measurement is fixed, there will be infinite significant figure. Okay, if measurement is fixed, then it will have the infinite significant figures. Examples: pi. So pi value 22 by 7 is fixed. Okay, pi value 22 by 7 is fixed. So now it will have the infinite significant figures. Now some of you may imagine this one also a square. Okay, so now square length is a. Now this length is, if it is fixed, okay, then its area, suppose a square, then it will have the infinite significant figure because its measurement is fixed. When it is fixed, then it will have the infinite number of significant figures. Okay. Okay, so all the rules is finished. Now you pause it, okay, and read all the rules once. Okay, after that you do some of the questions that I'm going to give you. Okay, so you solve with that questions. So questions are: find significant figure. Number A 3.20. Number B 540. Number C 1.80 into 10 to the power 24. Number D 0.0080. Number E 4.50 into 10 to the power 3. Okay. Number F 3.20 into 10 to the power 4. Number G 0.02 into 10 to the power 3. Number H 540.0. Okay. Tell me how many significant figures are here. Okay, you pause it and write it, and then you okay, and then you see the answers here. So now 3.20, the 0 is after the decimal, so it will be called as significant figures. This 3 and 2 are also significant figures. Okay, so 3 significant figures we got here. Similarly here, this 0 is now without decimals, without decimal it is here, so it is not decimal. Okay, not significant figures. Only 2 significant figures are here. Yeah. These are the significant. This 0 without decimal means trailing zeros are not significant figures. Now here how many significant figures are here? The 0 will count as significant figures because of the decimal. So 1, 8, 3 significant figures. Okay. Now here this 0 will be not counted as significant figures because number is less than 1 and it is at the beginning, right? So this will be not counted as a significant figure. But this 8 will be counted non-zero digit, and then this 0 will be also counted because of the point it is appearing. So 2 significant figure. Similarly here how much we have? Right? 3. This is not significant figure. So 3 significant figure. Okay, next. Here how much? Here also 3 significant figures. Okay. Next, what do we have? What do we have? This 0 will be not counted, this 2 will be counted. So only one significant figures. What about this now? Okay, this 0 is at the last, whether you consider a significant figure or not. Before the decimals, yes, this 0 will be considered significant figures. Okay, in the context that, because we are considering this as significant figures, right? So this 0 is between the significant figures, so this 0 will be also considered as a significant figures. Okay, because this 0 is between the significant figures, right? This 0 is considered significant figures, and this 4 is significant figures, right? 0 is at the last or not? This 0 is at the last or not? So this one is significant figure, and this one is also significant figure. So this 0 will be also become significant figures. Okay, so 4 significant figure we have here. Okay, yes, that's all for finding the significant figures. Now we will move to the rounding of the figures. Rounding of the figures, why it is used, what is the importance is that sometimes we get non-repeating numbers, right? Like when we do divisions, after that there you will get 3.6666, 3.777, 3.737373. So at the times this rounding of figures are used. Okay, so let's learn how to round up the figures. So we'll round up the figures up to 2 significant figures. Okay, rounding of significant figures. Okay, rounding up to 2. Okay, we will do up to 2 only. Okay, so let's say, suppose we have this one examples 3.71 and 1 is their number 3.77. So now what the question that they are telling us to round it up to 2 points only, 2 significant. So here 3 significant figures is there. Now we have to round it up to how much? 2. So now how we will round it up? Okay, so now see here 3.71 is there and 3.77 is there. So now to round up this 2, you have to watch for the third figures. Okay, now this if third figure is less than, okay, if it is less than 5, then you reduce it. Okay, 3.71 will become 70 only. Okay, 7 only. 71 will become 7 only. Okay, 3.7 reduced if it is less than 5. Okay, now if it is more than 5, 7 is more than 5, this 7 is more than 5, then you increase this. Okay, increase this figure. Okay, the 7s will increase to 8. Okay, so it will be 3.8. Okay, you have to watch the third figure. This figure you have to watch to round up to second figures. Okay, if it is more than 5, you reduce it. If it is more than 5, you increase it. Okay, so 3.7 become 3.8, right? Because the 7 is greater than 5. That 3.71 become 3.7 only. 71 become 7 only. It is reduced because 1 is less than 5. Okay, next, if it comes like this 3.75, then what you will do? It is in the middle now, right? So what you will do if it is in the middle? If it is in the middle, okay, if it is in the middle, then you have to watch for the another figure. That is the fourth figure. Okay, suppose if it is like this 3.75, okay, if it is more than 0, if it is more than 0, okay, find any number 3.75. So if it is more than 0, then what you will do? You simply increase it. Okay, so 3.75 will become 3.8. Here also 3.8. If it is more than 0, okay, if it is more than 0, this number here, okay, if it is more than 0, then you increase it. Okay, now here, okay, we have increased it. Okay, 3.751, 3.752, to increase it. Now what happens if it is rated it up? Okay, what happens if it is like a 3.750 now? Okay, what we will do now? Right, if it was more than 0, then we would have increased it, but now it is 3.750. So what you have to do during these times, odd and even rows comes. Okay, so this number you have to watch, this number. Okay, 5 you have to watch, and before 5 what number is there, that one you have to watch. Okay, if it is odd, okay, if it is odd, it will increase. If it is odd, what happen, it will increase. Okay, if it is 3.650, okay, if it is odd, it will increase. That means this will increase, this will be 3.8. now this figures you have to watch again. Here also the same things only, 3.650. now before 5 you have to watch that numbers, digits. Now if that digit is even, if this digit is even, then it will decrease. Okay, it will what, decrease. If it is even, means it will decrease. Okay, so 3.650 will be only 3.6, it will reduced. Okay, so this is all about the rounding of the figures. Okay, you do it, you tell me number A. Okay, what will be the answer here? 3.450, and then we have 3.950. Tell me what will be the answer here? 3.450 and then 3.950. So before 5 what you have? 4. 4 means even, right? Even means it will decrease, so it will be 3.4 only. What about this? 3.950 is there, right? 9 means what? 9 means what? It will increase, right? So increase means 1 will come here, so it will be 4. You can write it as 4. Okay, 9 means it is what? Odd. Odd means what? Increase. Odd means what? Increase. This one is what? Even. Right? Even means what? Even means it will decrease. Okay. So this is how we find the rounding of the rules. Now we will go to the next, that is algebraic expressions of the decimals. Okay, algebraic expressions of the significant figures. Algebraic expression means addition, subtraction, multiplication and division. Okay, algebraic expression of significant figure. Okay, first we will see addition or subtraction. So now you have to remember this, while doing addition or subtractions. Okay, the final results, whatever after addition and subtractions, whatever we'll get, the final result should have the decimals. Okay, then had the before the original numbers, how much decimal it had. In the final result also we should have the same decimals. Okay, the numbers that have the minimum decimals. Okay, in the result also we must get that much number only after the decimals. Okay, first you write it down, after that we'll do. Okay, the final result should have the decimal as that of original. The final result should have the decimals. The final result should have the decimals as of originals with minimum. The final result should have the decimals as the original number, as of the original. You write here a number as of the original number with minimum decimal. Okay, minimum decimals. So now here what does it say? The final result. Okay, whatever final result we get, the final result should have the same decimal as that of the original number. Okay, with the minimum, the one which have the minimum decimals. In the final result also we should have the same decimal points. Okay, see here like this examples. So suppose I have this one. Okay, suppose I am adding this one, 1.56 plus 1.56. Suppose 1.6 and 1.5. After rounding off, okay, after rounding off, it should have the same decimals. So now see here, after decimal only one digit is there. After decimal only one digit is there. After decimal two digit is there. So final result should have only one decimals after the one digit after the decimals. Okay. Let's write it down. Okay, suppose we have add now 1.56. Okay, 1.56 and then 1.5. Okay, we have this one now 6 0 point then 3 we got, right? 3 we got. So now after rounding up, see this is the one digit. Okay, after decimal. So the final result, okay, whatever the final result will get, that should also have only, okay, after rounding up, it should also have only one decimals, only one number after the decimals. So this 0 is there. So that means after point only one number, okay, should be there after the decimals. So this is the final results. Okay, one decimal in final result. Okay, so the minimum decimals which have the minimum decimals of the numbers which have the minimum digit after the decimals will determine the results. Okay, the results will also have the same digits after a decimal as that of the original number, okay, with the minimum digit after the decimals. Okay, so let's do one more examples. After that we will go to the next, which is multiplication and division. Suppose now there is subtraction. Okay, 32.56 minus 12.5. So do this one. What will be this? Okay, so 32.56. Okay, it will be 12.5. So what will be this? It will be 6 only, 0 point and then 0 2, right? After addition. So only one decimal, only one digit, right? Only one digit, right? After decimal, only one digit is there after decimals. That means after round off, after we round off, we should have only one digit. So 20.0. Okay, this after rounding off. Okay, 20.0 is the final result. Okay, 20.0, one digit after decimal. Okay, this one you have to remember. After rounding up, okay, after rounding up, you write it here. After rounding, we should have only one digit after the decimals. Okay, next, now multiplication and divisions. Now multiplication and division is also same, but here not decimals, here significant figures. Okay, multiplication and division. Okay, so when you do multiplication and divisions, it should have the same number of significant figure as that of the original number with the least significant figures. Okay, first let's write it down. After that, with the help of example also you will understand. Okay, the final results should have same significant figure as that of original number with minimum significant figures. Okay, so if there is, when you are doing multiplications, when you are doing divisions, so that time you observe which one have the least significant figures. So in the result also the significant figure should be same. Okay, let's take examples. Suppose we have this one, 1.35, okay, then into 1.2. So how many significant figures here? There are two significant figures. Okay, and then here three significant figures we got. Okay, here how many significant figures? Two significant figures. Now when results will comes, in the result also there should be only two significant figures. Okay, because minimum we have to see. Okay, so now let's do multiplications. 1, 3, 5, 12. So do it 2 5 is 10, 3 is 6, 2 3 is 6, 1 7, 2 1 is 2, 1 5 is 5, 1 3 is 3, 1 1 is 1. So 0, 2, 2 3, 5 1 6, 1. Okay, 1, 2 1 3. So 1 2, it will be 3, right? It will be here 1.620, right? So now after rounding off, okay, after rounding off there 1.3, only two significant figures, right? So the final result of the rounding also, it should have only two results only. Okay, so what happens after rounding off? Okay, after rounding off, this 1.620 will become only 1.6. So this is our answers. Okay, after rounding only two significant figures. Okay, only two significant figures we should have. Okay, similarly one example you do now divisions. Suppose we have this one, 33.5. Okay, 3.5 divided by 7. You do this one. Okay, 3.5 divided by 7. So how much you will get? So you will get 0.5, right? 0.5 you will get. Okay, 35. Okay, divided by 7. 7 5 is 35. Point is the point. Okay, so now how many significant figures? We have only one significant figure, right? So this one is only one significant figure. So this one is the correct one. Okay, so you practice some of the questions. Okay, so this much is enough for us. So this is the end of the class now. So study well and all the best. Thank you.